All right, so the RevD PCBs came in today, and I got them at about 5 p.m. and it is 10:40 p.m. So it's been just almost 6 hours. And here's one built, which is nice. I was able to build quantity 1 from scratch, including writing the position file because I hadn't actually done the centroids file for the pick and place machine and troubleshooting it. So pretty nice to be able to build quantity 1, the first one, in 6 hours. That's a huge improvement from before. And I just wanted to kind of go through the improvements and differences between the two. And so this is the RevC, which is all of the open beta ones. And then this is the RevD. And the first thing you'll notice is that the RevD is green. The reason I did this is that the green solder mask can do a finer pitch, and so these finer pitch parts I was having to do a ton of rework. In fact, every single one of these RevC ones, there's 6 of these, there's 5 of the 6804s, and then there's a 6820 underneath here. They have a very tight 0.65 millimeter pitch, and I pretty much had to rework every single one of those on every single one of the open beta ones. On the RevD, that when I just built the one here, I had to rework 2 of them, but they were pretty minor reworks, so that new solder mask is pretty good. I also changed the mask opening and the footprint a little bit so that there'd be less solder on these guys. So that's, it saves me a lot of time. The biggest difference is the grid charging. You can see if you look between the two here, the open beta one has this small triac here. The RevD one has a much larger triac with a heatsink on it. And that's so that we can use the larger grid charger at the worst case operating temperature in Phoenix. Hopefully, we'll have to see. Of course, LiBCM can measure the amount of current that the grid charger is putting out, and so it can limit that based on the temperature if the cabin temperature is too hot, for example. But anyway, this is going to give us a lot more headroom on the grid charging with that 2.1 amp grid charger. Other changes, you can see that this section here, which is kind of empty before, is now fairly full. I put on a completely separate 12 to 5 volt, or really the DC output here to 5 volt converter. 5 volt is what runs most of the logic on this thing. And that's because this chip is just impossible to find. I bought 100 of them last May, and I will build the first 100 of these with that chip, and then we'll use lower power. And if I still haven't received the other 500 of these that I ordered, whenever it is that I've built 50 of these, then I'll switch over to this circuit. Now this is going to be my board, and I put the new circuit on. I know the old circuit works, so I just didn't populate the old circuit there. So the intermediate voltage here, these may look like the same power supplies, but this is actually outputting 12 volts. So the input here is the battery voltage, and the output is 12 volts on the open beta. It's 15 volts here. That shouldn't really make a difference on anything because everything on the board runs at 5 volts except for the fans. For the fans, I'm basically doing diode drops. So when the fans are on, I'm trying to recreate that 12 volts. So each one of these in-channel transistors here is literally just diode dropping across its body diode. And that is dropping our voltage 2.1 volts, so it'll get us down to about, it's actually closer to 2.5 volts. That'll get us down to our 12.5 volts. These fans are only rated to 13 point something volts, and so we're going to just lose some heat here. It won't matter. When the fans are running, they'll be slightly less efficient. Whatever. So yeah, there's a bigger diode here for the grid charger again, for the larger grid chargers. The board can actually tell too which version it's plugged into, so you could swap these Arduino shields or the actual PCBs here, and the functionality is going to follow the actual board. I just have some pins that it can look to see, oh, I'm a RevC board or I'm a RevD board, and that way the logic doesn't have to change. You don't have to configure anything. If you did connect the 2.1 amp charger to this circuit board, then LiBCM is going to just limit the output current to say 600 milliamps or 1 amp, whatever the maximum value is here. But for the most part, they're the same. I haven't done any testing on this one. Of course, I'm going to. The thing I'm going to be testing the most here is the grid charger, and then of course this 15 volt output voltage being different, and then this new 15 to 5-volt converter as well. I've mentioned this guy before. It is less efficient, which kind of sucks, but you know, hopefully I don't have to build this onto the boards. I'm really hoping that those, you know, this power supply that I have like 500 of them backlogged on will show up first. But if not, this is what we're gonna have to use, and there is a penalty here for it. It's not small. It's not huge. I think it's like 20%. I don't remember. So if something was gonna last for 6 months on this guy, it'll last for, you know, 4.5 months here or whatever. But hey, that's what you do. You're in a supply shortage. So the one part that I am missing anything of, the one part that's going to keep me from shipping more than 50 of these, if it doesn't show up, is the LTC 6820, which goes right there. And I've ordered lots of them at this point, many more than I will ever use for LiBCM. I'm just ordering them from every distributor, and it sucks to be part of the problem of backlogging things, but at the same time, if I don't get more of those, I can only ship 50 more of these, and I don't want to do that. I want to ship hundreds of them. So anyway, yeah, that's it. There's a couple of small changes on the back. Basically, I moved some of the temp sensors plugins a little bit. On the RevC, so the open beta, it was possible that you could break this temperature sensor off. And also, when you plugged this one in, it was really tight. And so I moved it down some. I'm not 100% happy with where I moved it to. It works. You know, the first goal moving it down was to make it not bind when you plug it in. It's the shortest cable basically, and as you're, you know, putting it all together, it's the one that can get taut. But anyway, it does all work. Let's see, I moved this one slightly here too, but not enough. The goal was to make it to where you couldn't hit it with the little blade there, but you still can, whatever. But yeah, you know, mechanically and build up, it looks great. I don't have any feedback. It looks like it's gonna work. So yeah, we just need to chonk through it electronically now. And I'm gonna start doing that now, but just wanted to post a quick video here. And yeah, I'm gonna start out, make sure this supply is stable, and assuming it is, which I think it is, I prototyped it before, then I'm gonna move straight to the grid charger and test that out, and then I'll go do the fans after that. But yeah, that's basically it. Thanks for watching.